Welcome friends. In this video we are going to learn about instrumentation amplifier. Many industrial systems, consumer system and process control systems require a accurate measurement of physical quantities like temperature, pressure, weight, etc. For example, a sugar factory requires a measurement of flow, level and temperature of juice, and plastic factory require a accurate measurement of temperature. So this measurement of physical quantities is generally carried out with the help of a device called as transducer. A transducer is a device which converts one form of energy into another. For example, a thermocouple converts the heat energy into electrical energy. Microphones convert the sound energy into electrical energy, and force like mechanical energy into an electrical energy, etc. But most of the transducer outputs are generally of very low level signals. Such a low level signals are not sufficient to drive the next stage of the system. Hence, before the next stage, it is necessary to amplify the level of such signal, rejecting the noise and the interference. Hence, general single-ended amplifier like high gain emitter amplifier is not suitable to amplify such signal. For rejection of noise, such amplifiers must have high common mode rejection ratio. Hence, a special amplifier is used to amplify such signals. The special amplifier which is used for such a low level amplification with high CMRR, high input impedance to avoid loading, low power consumption and some other features is called an instrumentation amplifier. Instrumentation amplifier allows one flexibilities, that is, need to change the gain by changing only a single resistance value. Commonly, the differential amplifier, we are using differential amplifier. The disadvantage of differential amplifier is that the gain of the amplifier cannot be easily changed. We would need to change two resistance value and still maintain equal ratio between R2 by R1. So this is the differential amplifier circuit. Here, if we need to change the gain, easily change the gain means we need to change two resistance value, that is we need to change R1 and R2 resistance value, and also we have to maintain the equal ratio between R2 by R1. But instrumentation amplifier allows this flexibility. So here we need to change only one resistance, single resistance. That resistance is here I denoted by RG. So here we are using potentiometer to varying this resistance value. So using this resistance we are change the gain. So this is the circuit diagram of instrumentation amplifier. In this circuit diagram, two non-inverting amplifier, that is A1 and A2, are used the input stage, and a differential amplifier. This is differential amplifier. Differential amplifier A3 is the second stage or amplifying stage or output stage. So here we are using two stages, that is input stage. In input stage we are using two non-inverting amplifier, and the output stage we are using differential amplifier. Let's discuss about the gain of the instrumentation amplifier. So here we are using differential amplifier circuit at the output side. So the output voltage of the differential amplifier, we know the output voltage of the differential amplifier is V0 is equal to R2 by R1 into VO2 minus VO1. That is VO2 means that is the output of second non-inverting amplifier. VO1 is the output voltage of first non-inverting amplifier. So these are the two input voltage of this differential amplifier. So next we will calculate V02 minus V01 value. We are going to calculate V02 minus V01. So for that we are considering the first stage. So first stage there are two non-inverting amplifier. So here the node A potential of op-amp is V1. So here the input voltage is V1. The potential of node B is also V1. So here B potential voltage is V1 means the node 1 voltage is also V1. So here the voltage is V1. And node C of the op-amp A2 is V2. The potential of node D is also V2. Hence, the potential of node 2 is also V2 because the node D is connected to node 2. So here we are going to apply Ohm's law between node V01 to V02. That means the output voltage of the first op-amp to second op-amp. So here we are going to apply Ohm's law. So here calculate the current I values. The same current flows between V01 and V02. So I is equal to, what is Ohm's law? I equal to V by R. So the potential difference between these two nodes is V01 minus V02. So V01 minus V02 divided by RF1 plus RG plus RF2. So here the resistance, there are three resistance is connected between V01 and V02, that is RF1, RG, RF2. So we are adding all the resistance value here. So RF1 and RF2 is the non-inverting feedback resistance. So both are same. So we are using RF1 is equal to RF2 is equal to RF. So substituting RF here means we will get I is equal to V01 minus V02 divided by 2 RF plus RG. So that is the equation number 1. So next we are using Ohm's law. We are going to apply Ohm's law between node 1 and 2. So here node 1 and 2 the potential difference is V1 minus V2. So I is equal to V1 minus V2 divided by RG. So that is equation number 2. Next equate equation number 1 and 2. We will get like this. So V01 minus V02 divided by 2 RF plus RG is equal to V1 minus V2 divided by RG. So if you are finding V01 minus V02 value here, we will get 2 RF plus RG into V1 minus V2 divided by RG. So V02 minus V01 is equal to, take this is equation number 3. So here I am taking minus outside. So we will get V02 minus V01. So here V2 minus V1. So substitute this V02 minus V01 in the second stage output voltage of differential amplifier. That is V0 is equal to R2 divided by R1 into V02 minus V01. If you are substituting here, we will get V0 is equal to R2 by R1 into 2 RF plus RG divided by RG into V2 minus V1. So if we are here, we are dividing by RG on both the resistance value means we will get 1 plus 2 RF divided by RG. This is the output value of instrumentation amplifier. If we calculate the gain means that is V0 divided by V2 minus V1 is equal to R2 by R1 into 1 plus 2 RF divided by RG. This is the gain of differential amplifier. Sorry, this is the gain of instrumentation amplifier. So instrumentation amplifier that is satisfy some requirements, that is easier gain adjustment. So easier gain adjustment means this differential amplifier here we need to change one single resistance value we can adjust the gain. Second one, it will provide high CMRR. The output of the transducer when transmitted with long transmission lines has presence of large common mode noise voltages. The instrumentation amplifier must amplify only the differential input, completely rejecting the common mode input component. Thus, it must have ideally infinite CMRR. So, it gives high input impedance value and low output impedance value. These are the advantages of instrumentation amplifier. Thank you, friends.